Hi everybody. I'm not there today, but I'm hoping that I can get you through this lab. So I'm going to give you a quick little discussion about what you're going to do, and then we're going to give you the rest of the class to try and do the lab in partners or maybe groups of three. Actually, I think groups of three would probably be best, so you can pick those. Yeah, let's get right into it. So I have here on the right side what the lab looks like, and I have here on the left side sort of what you're going to be doing. And I hope that it'll make sense. So the entire idea here is you're going to prove, using conservation of energy, how much energy gets lost with every successive bounce of a ball. And then we'll talk next week about what actually happens to that energy. But we're going to look at the procedure, so read on with me. We're going to measure the mass of a golf ball and a tennis ball and using the scale in the prep room. So you're going to go behind and you're going to measure the mass of a golf ball, and you're going to write that down in the first box. And I'm going to pretend that the golf ball is 1 kilogram. And because the golf ball is not going to change its mass, it's going to be 1 kilogram for each trial. So I'm going to go ahead and just write that in, 1 kg, 1 kg, 1 kg, 1 kg, and 1 kg. Now it really isn't a kilogram, but you guys are going to take your golf balls and measure them in the prep room, and then you're going to divide that number by 1,000 to get the mass in kilograms. You're then going to drop the golf ball from a height of 2 meters and record the height of each consecutive bounce for 5 bounces. And this is a little troublesome, so I'm going to walk you through the first couple of bounces. And the data that you want is you are going to record the bounces in the table. So I've already done the first one for everybody. You are going to drop the ball so here's the ball. You're going to drop it from a height of 2 meters. And we're going to say that is the 0th bounce because it hasn't bounced yet. So you're going to drop the height from the ball from 2 meters, and what you're going to do is you're going to calculate the amount of potential energy that is in there. And if you remember, potential energy is mgh. So for me, my mass is 1 kilogram, gravity is negative 9.8. Meters per second squared, and the height is 2 meters. So what you're going to get to do is you're going to take your mass, which for me is 1, for you it won't be, times 9.8 times 2 meters. And for me, my potential energy is 19.6 newtons. You are then going to drop the ball, and the ball is going to fall and bounce back up to a height that is less than that original height. So I'm going to say that is bounce 1. And let's say the golf ball bounces back up to this height, whatever this height is. And for the sake of argument, let's say that that height turns out to be 1.5 meters. So I'm going to write down in the table 1.5 meters. And what I'm going to do next is calculate the potential energy here. And for this, my mass is 1 kilogram times 9.8 times 1.5. And it's going to be 14.7 joules. Well, now here's the trick. I started out with 19.6 joules, now I have 14.7. So how much energy have I lost? And I blacked this out because you don't lose anything on the first, or from the original height, but you lose energy in that first bounce. So now I get to subtract, and it says here, calculate the potential energy loss in each bounce. Well, PE loss is PE of the prior bounce minus the PE of the bounce. PE that you started with, 19.6, minus the PE of the first bounce, which is 14.7. So 19.6 minus 14.7, that means I lost 4.9 joules. I hope that makes sense. Okay? And then we're going to let it fall again. And now it bounces, and let's say it bounces back up to, instead of 1.5 meters, let's say it bounces to 1.25 meters. Okay? So now I would do that exercise again where I calculate the amount of energy that is potential energy at there. M, which is 1 times 9.8 times 1.25. And now I've got 12.25. Okay? And you're going to let the ball keep bouncing for 5 bounces, and you're going to record every height for each bounce, and then you're going to record the potential energy that's associated with that height. Now the beauty of this is you don't have to do it all in one shot. When you allow the ball to bounce, if you know where it went back to, you can catch it, do a little calculation, and then drop it from that point again. Okay? So I'm not going to tell you how to measure, I'm going to suggest you go near a wall because it'll probably be easier for you to hold the meter sticks near the wall or even tape them to the wall so you can drop the ball and sort of see where it goes. All right. So then once you've got the potential energy lost, you can again, let's see, 12.2, 14.7 minus 12.25 is going to be 2.45 joules lost. Okay, so I hope you see how this works. The next, and the thing that I'm very curious about, is with every single bounce, how much energy do we lose as a percentage? And why do I care about this? Because I'm a golfer. And my question has always been, you know, the more you play with a golf ball, I've always wondered, does the amount of bounce that the golf ball has get less and less and less? And this is, you know, the lab that's sort of trying to see what the deal is. So the first bounce, I'm curious about how much potential energy we lose as a percentage, and then how much do we lose as the second bounce, and then how much do we lose at the third bounce, and the fourth bounce, and the fifth bounce. And for me, I want to know at what point do I lose so much energy that I just want to throw the golf ball away. So let's look at the percentage. So calculate the percentage of potential energy lost. The percentage lost is the PE lost over the PE of the prior bounce times 100%. So we're going to say 14.9, so here's the percentage PE lost. 4.9 joules out of 19.6 joules times 100%. So 4.9 out of 19.6 equals 0.25 times 100%, which is 25%. Okay, and what that really means is, okay, I started with 19.6 joules of energy. In the first bounce, I lost 4.9 joules of that 19.6 joules. Okay, so I lost 25% in that first drive, or in the first bounce. In the second bounce, I started with 14.7 joules. I lost 2.45 of them. So the same deal, 2.45 out of 14.7. That is 16.6 joules. So I'm sorry, not 16.6 joules, 16.6%. And you'll be able to see as the bounces get smaller and smaller, you're going to lose a different amount of energy. Now again, I don't know how much I lose per bounce. I'm not using real numbers. I haven't actually done the experiment I did last year, but I didn't do it for you this year. But you're going to figure out at what bounce you lose energy, or where you lose the energy. And then the other good question is, what's the velocity of the ball at each, as it's going to hit the ground? So on the 0th bounce, when I drop it from 2 meters, how fast is it going when it hits the floor? How fast is it going after it bounces? How fast is it going after that, and after that, and after that? So the way I can do that is I can realize that my potential energy was 19.6 joules. That gets turned into kinetic energy, and kinetic energy is 1/2 mv squared. So forgive the, it's going to be a little shaky, but my PE was 19.6 joules. So when the ball was up top, all of that PE was, well, all of that energy was potential. As it falls down, that potential energy becomes kinetic energy. So when it hits the ground, or just before it hits the ground, I'm dealing with 19.6 joules of kinetic energy, and last time I checked, we have an equation for that, which is 1/2 mv squared. So 19.6 joules equals 1/2 times my 1 kilogram v squared, and then we can solve for the velocity. And I will do that right now. I'm going to take 19.6, multiply both sides by 2 to get rid of that 1/2. Divide both sides by 1 to get rid of the 1, and then we're going to take the square root of that. We should end up with 6.26 meters per second. Meters per second. Okay? And then you can do the same thing, where instead of you starting it at 2 meters with 19.6 joules, you can start it at 1.5 meters with 14.7 joules. So instead of 19.6 here, you would have 14.7, and then you can figure out a new velocity. So you're going to do that, you know, this whole process over and over and over again for a golf ball. And then I've always been curious about tennis balls. So the first chart you're going to have is for the golf ball. The second chart you're going to have is for the tennis ball. And then after that, you can answer all of these questions on the back of the paper. And, I hope it should take a good chunk of the block period. Let's try and have this for me on Monday, and we'll have a good discussion about what's going on in terms of, basically who's a better balancer. Is it a golf ball or is it a tennis ball? Which one can I hang on to longer? Does a tennis ball lose less energy every time it bounces compared to a golf ball? So that's sort of what you're doing. I hope that this makes sense in terms of doing the math. And that's it. I wish you the best of luck. And if there are any issues, I'll have my phone on me. So if you feel like emailing me from your phones, go for it. And I'll try and answer any questions. But I think I pretty well answered, or I hope I walked you through this. Alrighty? Have a great weekend, and I will see you all on Monday. Toodaloo!